Hello, my dear sisters and brothers. I hope you are really doing well. Me, I'm fine, absolutely fine. Now, in the last video, we talked about stress, strain, and elastic limit. I hope you remember all of that. In that video, I told you about an order. I told you to remember this order. So, what's the order? The order is like this. First, you need to apply deforming force on a body. Right? It will give rise to deformation in the body. And once there is deformation, restoring force will be developed inside that body. Right? So first comes deforming force, then comes deformation, and then comes the restoring force. I hope you remember that. Right? Now, what I'm about to tell you right now, it's pretty much intuitive. There is no surprising fact about it. Suppose you are doing an experiment with some kind of elastic material. With a body which is made up of some kind of elastic material. And then you have started applying a deforming force on the body and you have decided to increase the deforming force on that body. So you know what's going to happen, right? If you gradually increase your deforming force from a lower value to a higher value, but do stay within the elastic limit, right? You want your body to remain elastic. You remember elastic limit, right? It is a maximum stress which a body can endure before it loses its elasticity. So staying within the elastic limit, if you go on increasing the deforming force on a body, the deformation inside the body will also gradually increase. তার মানে হচ্ছে when the deformation is getting increased, the strain developed in the body will also gradually increase. And if the deformation is increasing, it means that the restoring force inside the body is also gradually increasing. তার মানে যে স্ট্রেসটা ডেভেলপ করছে ওটাও কিন্তু আস্তে 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 ইনক্রিজ করছে. So within elastic limit, when the deforming force is not very large, আমরা বুঝতে পারছি stress developed in a body increases if you increase or if strain formed in the body increases. Right? So it is based on this fact there was a scientist whose name was Robert Hooke. He gave us a law. It's called the famous law of elasticity, Hooke's law in elasticity. So I'm going to write that. It's called Hooke's law in elasticity. And in that law he said that within elastic limit the stress developed in a body is directly proportional to the strain formed in the body. Once again, it's not surprising. It's not surprising that stress is proportional to strain. It's not the other way around. Right? Because stress to develop করে তাই না স্ট্রেস আর স্ট্রেন দুজনেই কিন্তু বডিতে ফর্ম করে বিকজ আমি ডিফর্মিং ফোর্সটা অ্যাপ্লাই করি বলে সো দিস টু আর চাইল্ড অফ ডিফর্মিং ফোর্স রাইট বাট যখন আমি ডিফর্মিং ফোর্স অ্যাপ্লাই করি তখন স্ট্রেন ফর্ম করে আর যখন স্ট্রেন ফর্ম করে তখন স্ট্রেস ডেভেলপ করে তার মানে কে কার উপর ডিপেন্ড করলো স্ট্রেস ডিপেন্ড করে স্ট্রেনের উপরে দ্যাটস ওয়াই দ্য ল ইজ লাইক দিস স্ট্রেস ইজ প্রপোর্শনাল টু স্ট্রেন within elastic limit, right? So in other words, the ratio of these two quantities, stress and strain, it is a constant, isn't it? And this constant is what is known as modulus of elasticity. It's called modulus of elasticity and it is denoted by E. Take Remember, the modulus of elasticity is a property of the material of the body. So it's a property of the material of the body. So it means that a body which is made up of steel and there is another body which is made up of copper, because these two are made up of different materials, So steel will have a different value of modulus of elasticity and copper would have a different value of modulus of elasticity. Right? The unit of modulus of elasticity is same as that of stress. Right? Because E is equal to stress by strain. Strain has no unit, but the unit of stress is Newton per meter square. So that is why the unit of modulus of elasticity is Newton per meter square. The physical significance of modulus of elasticity is this. It gives you an idea about the elasticity of that material. It tells you how elastic that material is, right? So it's obvious that higher the modulus of elasticity of the material, more elastic is that material, right? All right. Now in the next video, we are going to learn more about this modulus of elasticity. In the next video, we are going to learn that there are 3 kinds of modulus of elasticity a material could possess. They are called Young's modulus, bulk modulus, and modulus of rigidity. Till then, goodbye and thank you.